Okay, to find the time complexity of a recursive equation. Okay, how do we know that this is a recursive equation? It's because you see this is Tn, right? And it is function of time of the same function again, Tn, but smaller size of input, right? So it's expected to be a recursive equation. And we have to analyze it by using like recursion tree to visualize about how it goes, right? And you see the initial condition here, right? Which is the return point, turning point, something like that. So to find the time complexities, right? We know that Tn, right? You have to solve the function. No, you have to solve the input of side n by using this recursive function, whatever function, but you analyze the times like this equation, right? So the first, you solve the problems of size n, okay? Okay. And then, right, when it call into the recursive function, right, it will be working with Cn. It will give you constant time and it will call itself 2 times with smaller size of input with n divided by 2, right? Tn divided by 2, okay? And this is from one equation. And then for the next step, Tn divided by 2 will call through, right? And you know that Tn divided by 2, you substitute to the function, right? Will equal to 2 of Tn divided by 2 divided by 2. Divided by 2 times 2 is here, right? Plus Cn divided by 2, right? Because there are n. You substitute n with n divided by 2 and you got this. So in next step, right, Cn is the same, right? For n divided by 2 function, you will take Cn divided by 2 constant time, right? With 2 of Tn divided by 4, right? Right, Cn divided by 2, you have Tn divided by 4. Sorry, Tn divided by 4, 2 function, right? And then you do it, right? Until it is equal to T1, okay? T1, okay? So, in each step, right? What are the times that this algorithm takes? That is Cn, right? Has Cn times. And in this step, it has Cn divided by 2 multiplied by 2, right? Which is equal to Cn, right? And in here, if you substitute Tn with n divided by 4, it is equal to 2 times 3n divided by 4 times 2 plus Cn divided by 4, right? And each one is Cn divided by 4. And it will take Cn divided by 4 multiplied by 4. You take Cn times. And the time complexity, you have to combine the time complexity of the first step with the time complexity of the second step, right? And so on, right? Until this one, it is expected to be whatever things Cn divided by something multiplied by this. And it's expected to do like Cn in every step, right? You have to add all it together. So, and you don't know how long that it will add it. Time, x time, right? And what is x, right? And as we see, right, by analyze, you know that from the first step, the size of input is equal to n, right? And then the size of input will change to n divided by 2. And the next step, the size of input is n divided by 4. And then n divided by 8, right? And so on, right? Right? Or it will equal to n divided by n2 to the 1, right? This is 2 to the zeros. And this is n divided by 2 to the 2, n divided by 2 to the 3, right? And so on, right? Okay? And this is 2 to the zeros in this step, right? 2 to the 1, 2 to the 2, right? Until 2 to the whatever, but it equal to 1, right? So what is it? If we don't know, right? We make it as an I time step. And you do know that n divided by 2 to the I equal to 1, right? Or n equal to 2 to the I. And you know from logarithm that a กำลัง a superscript equal to b, right? So this will equal to log 2n equal to I. Equal to, right? Right? Okay, so you know that I is equal to log 2 times n, okay? So you have to do addition for the log 2 times n times, log 2 of n times. Therefore, I have space here. Therefore, the time complexity is Cn. And do addition log 2 n times, right? Multiply by log 2 n times, right? And when the size of input is big enough, we don't care about the constant, right? So this algorithm is supposed to have a time complexity equal to n log 2 of n. This you can answer. Thank you.